Yes, Jan has introduced already. My title contains the word poop, so I want to get through with the toilet humor right away, and we can go to the real stuff. It will not be about poop today, don't be afraid. It will be about party poopers, which is luckily also not exactly that. Also not that, party poppers, although we will have some jump scares in my talk. It will be about party poopers, so about those persons that kill the vibe on any party, and I'm sure that you have encountered some of them in your life. Okay, so who is the party pooper in our setting? It is the famous tumor suppressor p53, also known as the guardian of the genome. This is because p53's main function is to safeguard our DNA. So if you would ask for a Polaroid picture of p53 and its bestie, this is it. So we see p53 in blue here and a strand of DNA in pink. But I find this rather complicated. So when I think about p53 in my head, it looks like that. It just has 4 subunits that look the same. And please believe me, it is totally unintentional that this looks like the Microsoft logo. But if there's somebody from Microsoft in the audience, please hit me up later about sponsoring. So, okay, we know the main character of our story. But what's the story? We're talking parties. We're talking that kind of parties that happen in your body every day, right now at this moment. We are talking about your colon, your large bowel. And this is what it looks like. So if you would imagine your colonic lining, your epithelium, as the setting for a house party, we would have epithelial cells here, connective tissue, mucus, and a bunch of other cells. So, for example, immune cells chilling in the basement, or the microbiota dancing on the rooftop terrace, if you will. So whenever there's injury happening to your colonic lining, for example, because you had that sketchy sushi the other night, what happens is that the microbiota, the bacteria, will come into contact with your epithelial cells. Immune cells will also starting to get activated, so there is damage occurring to your epithelium, and ultimately some of your epithelial cells will die. But don't you worry, the self-healing capacities of your body is amazing. So what happens is that your epithelium will throw a regeneration party. It will just make up for the lost cell mass by dividing massively. So now, as with any party, it can get too messy, too exciting, and this can mean chaos. And chaos in a biological context can mean DNA mutations and genetic aberrations and ultimately cancer. And we don't want this to happen. So we need a party pooper to step in. Somebody to stop this from happening, and this is exactly what we found what p53 is doing in this context. So p53 is terminating this regenerative state and making the epithelium go back to the normal state. So p53 is making the party stop. Okay, so now, because p53 is a very famous protein, if you would translate this to our party setting, it's like a neighbor's coming in and turning the lights on, saying, everybody out, party's over. But this neighbor cannot be any neighbor, it has to be somebody really famous. So imagine your neighbor is the pop singer Pink, and Pink is coming over to your house to stop your party. And now you might wonder, well, the pop singer Pink, she's not really famous for stopping parties, she's rather known for stuff like that. So getting the party started, right? And well, this is similar here in this context because p53 has not been known of terminating regeneration in this context. In fact, p53 is not there in the homeostatic state, so when everything is normal in the tissue, but it gets activated massively during regeneration, and then it will stop the party. Okay, so no problem at all, right? Well, here's the twist. Sometimes Pink isn't home. Maybe she's on world tour, maybe she's on vacation. And in the biological setting, this means that p53 is not there because, for example, it is mutated or just deleted. And this is oftentimes happening in precancerous lesions or in colorectal cancer. And then basically, the party never stops. There's nobody there. There's no party pooper that will stop the party. And regeneration will go on and increase the risk of cancer. So basically what we're trying to do is finding other party poopers, finding an alternative protein, an alternative pathway that can stop regeneration and stop cancer from happening. So, you know, when pink is not there, we would take anybody. We would take Beyonce, we would take Adele. You know, we would even take your grumpy landlord that comes over at 10 p.m. and calls the cops because the music is too loud. It really doesn't matter. We just need that party to stop. So I want you to take with you from this talk is that your gut is constantly throwing wild parties. But you have a party pooper. You have P53 or pink who's coming and stopping the party. And we are trying to find other party poopers to make the party stop. Because you can imagine that cancer is the worst hangover you can imagine. And this means, at the end, the party has to stop. Thank you.